Hello students. So today discussion is periodic classification of element, periodic table chapter. So this is very crucial chapter students, periodic, how the elements are classified, what is the need of classification, everything, what are the factors which influences all the elements, group wise, period wise, everything we'll discuss in this chapter. So first of all, to start the discussion, why do we need to classify the elements? We already classified the atoms into elements, and again why do we need to classify the elements? Students, you know the reason. I'll tell you. For example, students, you went to a library. In the library, you want to take a chemistry book. There are different racks. Like one rack is chemistry, other rack is physics, English. Different subject racks are there. You directly go to the chemistry rack and you select your book. Yes or no? In case if all the racks, all the books were mixed up, then what you have to do? You have to check each and every rack for your required book. Yes or no? Classification anywhere helps us to study in a easy format, to understand in a easy way. So here also classifying the elements, classification of elements helps us to understand the physical properties and the chemical properties easily. How it is done, how it is classified, that we'll discuss. So when it comes to the classification, students, Greek philosophers classified the nature, and even Indian philosophers also classified the nature into 5 categories. They are called as Panchabhutas. What are those, students? Air, water, fire, land and sky. Yes or no? Panchabhutas. So they try to classify, whenever classification helps us to study in a better way. So when it comes to the classifying the elements, there are early classifications are also being done, but you already know there are, from the olden times you don't have all 118 elements. Yes or no? So these elements were discovered over the period of time. So not all the elements were included in all these classifications. The first early attempt was done by the scientist Lavoisier. Lavoisier, students, he classified the elements, he tried to classify the elements, whatever the existing elements at that time. Of course, he didn't classify all the elements also, into metals and non-metals, that we already know about metallic characters and non-metallic characters. So he analyzed the properties. What are metallic characters, students? Malleability, ductility, sonorous, all these conduction of heat and electricity are called as metallic properties, and lustrous nature, they are called as metals. What are non-metals? Simply opposite, which are not. It's like non-malleable, non-ductile, non-sonorous. All these are non-metals and which do not conduct heat and electricity. So this is the very first attempt to classify the elements into metals and non-metals. So next, later on, the scientist Daubrennier's law of triads. This classification has some significance, students. Daubrennier's and his classification is called as law of triads. So what is the meaning of triads? Tri means 3. He classified 3 elements like a group. He classified 3 elements. You can see lithium, sodium, potassium, one group. Chlorine, bromine, iodine, one group. Calcium, strontium, barium. Like this, he classified certain triads, and like whenever any scientist is classifying the elements, he should give a statement why you classified that way, why only 3 elements, and that is called as a law. And here the law is called as law of triads. According to the Daubrennien, he states that the atomic mass of the middle element is the average of atomic masses of first and third element. For example, lithium mass is 7 grams, potassium mass is 39 grams. No, according to the law of triads, what is the mass of sodium? Find out. It is the average of first and third. That means 7 plus 39 by 2. 7 plus 39, how much? 46 by 2, which is 23 grams. Yes or no? And what is the mass of sodium? Exactly 23 grams. That's how it works. Does it work for all the triads? Means at that time when he classified, he got almost all the values. But now, so we have a very sophisticated techniques to find atomic masses so precisely. Whatever Daubrennier's gave the masses, they are not so accurate. That is only, this law is only applied for this triad only, even not applied for all the remaining triads. This law is not applied, only for lithium, sodium, potassium triad applied. Why it is applied? It's a simply coincidence. That's it. Does it really mean first and third element average is the middle? No, not like that. It doesn't work like that. So, but he classified, and you can see even in the modern periodic table also, you can see lithium, sodium, potassium in one group. Yes or no? Anyway, he tried to classify, that is okay, but the law which he said in this classification is absolutely invalid, and this law is also not applicable for the remaining elements at that time also. Only few elements he classified. So this law is completely invalid, students. So next of all, next law is given by the Newland, and his classification is called as Newland's law of octaves. Oct means what, student? Oct means 8. Newland, he classified the elements based on increasing order of atomic masses. So mainly in the olden times, atomic mass is the main criteria to classify the elements. So Newland also classified based on the increasing order of atomic masses. You can check the elements under Newland's periodic table, students. His periodic table starts from lithium. He didn't classify hydrogen. Why? I'll explain. He didn't classify helium also. Why? I'll explain. First lithium. What is the next element? Beryllium. Atomic mass, increasing order of atomic mass. Next boron. Next carbon, nitrogen, oxygen, fluorine. After fluorine, next is neon. He didn't classify neon. That means he didn't classify noble gases. Why? I'll explain. After neon, sodium. He again placed sodium under lithium. Yes or no? And he continued till chlorine. And he again placed potassium under sodium, and he continued. His classification is applied only from lithium to calcium only. This is Newland's periodic table. That doesn't mean the elements are not there at that time. Elements are there. Gold is there from ancient times. Yes or no? So, but he didn't classify. So now let's see what is the law behind this idea. The law is called as, simply you can see on the heading, law of octaves. You know what does it mean, students? Law of octaves. According to Newland, every 8th element in his classification resembles the properties of the first element. What is that? Every 8th element resembles the properties of the first element. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. So lithium, sodium is placed under same group or not, like top to bottom is group, under same group or not. Why? Why? Because lithium, if lithium is the first element, what is the 8th element? Sodium. Let's count from boron. 1, 2, 3, 4, 5, 6, 7, 8. Boron, aluminium has same properties or not? That's why aluminium is placed under boron. Like that, if you can check, count magnesium. 1, 2, 3, 4, 5, 6, 7, 8. So magnesium and calcium have same properties or not? So that's what he said. Why only 8th element? He should give us some reason, yes or no? Okay, whatever you said is okay. But why you saying every 8th element resembles the properties of the first element? Why exactly 8th element? You know what he said? He classified, he took a reference of music. He took a reference of music. You know what he said? What are the musical notes? Let's consider the Indian musical notes. Sa, Re, Ga, Ma, Pa, Da, Ni, Sa. Count from the first note. 1, 2, 3, 4, 5, 6, 7, 8. Once look at the first and 8th sounds. First sound is same as like 8th sound, yes or no? So he compared his classification to the musical notes. Like how does it work? Do they have any relation? This is absolutely invalid. There is no doubt at all. He is a lover of music, so simply he took that reference. So that doesn't mean there is a relation between the elements and the music. No, completely no. But his classification is okay. Whatever the elements he classified, that is correct. But the law he gave, that is absolutely incorrect. Sir, then how it is applied? That's a coincidence again. Still, that's a coincidence. But he didn't added other elements also, no students. You can also make it whatever the number by removing other elements, right? So if he had, why he didn't added noble gases? I'll tell you. Now, if he add a neon after fluorine, now count the elements from lithium. 1, 2, 3, 4, 5, 6, 7, 8. Does neon and lithium have any properties? No. If he is adding noble gases, his law will be completely ruled out. So simply he excluded. Even helium also. Even argon also. After chlorine, argon is not classified. Yes, sir, students. So what is happening? If noble gases were added, no more 8th element resembles the properties of the first element. He want that reference. So to maintain that reference, he left the noble gases as well as hydrogen also. And why not the elements after calcium? The elements after calcium, if you can check the if you can check the electronic configurations, students, after calcium, which elements are starting? D block elements are starting. Yes or no? D subshell elements are starting. D subshell maximum can accommodate how many electrons? 10 electrons. So how many elements are possible? 10 elements. How many configurations? 10 configurations. D1 to D10. Is it possible from D1 to D8? Is there any similarity? No. So they are not showing this first and 8th element. So that's why he can't exclude all the elements also. Simply he left. He didn't classify the elements after calcium. So his classification is only applied from lithium to calcium. You can see the same block of elements even in the modern periodic table also. But the law is invalid. The law is completely invalid. Got the clarity? So this is also one of the early attempts of classification, students, classifying the elements. Next is given by Lothermeyer. Lothermeyer classified the elements by considering the elements' atomic volumes, and he plotted a graph by taking atomic volume against atomic weight. So he got a series of these peaks. You can check on the screen these peaks, and he generalized the concept by taking, you can see the top element on the peak is lithium on the first peak, on the second peak sodium, third potassium, rubidium, cesium. So what he said is the elements which are in the same position in the graph, they belongs to one category. Of course this is true, but can we remember the why we are classifying the elements? To for us in a simple way, to study in a simple way. If we classify the elements, all the elements according to the graph's atomic volumes, look at here, it is clear. In the peaks at the elements are clear, these are alkali metals. Second is also okay, beryllium, magnesium, calcium, barium, alkaline earth metals. If you go down, look at the halogens, look at the transition elements. Can we exactly draw the elements which are in the point by point? Is it easy to study? No, it is more difficult. And when it comes to the atomic volumes, atomic sizes, atomic weights also, there are many exceptions are there for the elements. So this classification is also not completely precise, and this is also completely not followed because of many confusions are there which are assigned with this classification, Lothermeyer's curve. So the main point here to remember is atomic volumes against atomic weights. Next, Mendeleev's periodic table. This classification is very important classification, even according in the exam point of view also, students. Mendeleev's classification is very important. First of all, Dmitry Mendeleev is a Russian chemist. He classified the elements based on the increasing order of atomic weights. He also followed atomic weights, but he whatever the classification which is given to Mendeleev, that is absolutely valid. But there are some drawbacks are there that I will explain. So first of all, why it is valid? Not simply classifying. The law is there now which connecting all the elements in this classification. That should be valid, and his law is a valid law. And you can see the same law even in the modern periodic table also. The same law, except one change is there that I will explain. So Mendeleev's periodic law. Look at the law, students. What the law says? The physical and chemical properties of the elements are the periodic functions of their atomic weights. The physical and chemical properties of the elements are the periodic functions of their atomic weights. What's the meaning of this law? Once again read the physical. What are physical properties? Melting points, boiling point, density, solubilities, color, everything, taste. And chemical properties. What are chemical properties? How it reacts with oxygen, how it reacts with chlorine, whether it loses electrons, gains electrons, how many electrons, everything comes under chemical, right? The physical and chemical properties of the elements are the periodic functions. This is the main point. Are the periodic functions of their atomic weights. Ultimately classified the elements based on the increasing order of atomic weight. This is also clear. Physical and chemical properties also clear. What is the meaning of periodic function? You know, students, what is that meaning? Mendeleev classified the elements into groups and periods. These are groups, top to bottom, and these are periods, left to right. These are periods and these are called as groups. How he classified the elements? Based on groups and periods. And he said the elements present in the same group have similar physical and chemical properties. Which elements? Where the elements present in the same group or same period? Same group. So for example, I am just writing the numbers. If element 1 is placed here, element 2 is placed in the same group, yes or no? With similar property. Element 3 is placed in the same. These are not atomic numbers or atomic weights, simply numbering for the elements. That's it, students. So these elements, they have same properties. These elements are placed in the same group, but every time are they placed in the same period also? No, that is periodic function meaning. If one element is placed here in the first period, element is placed in the second period, next element is placed in the third period, then fourth period, next fifth period, this is called as periodic function, students. The elements which are placed in the same group, but every time they are placed in a different period. These elements have similar physical and chemical properties, and all these elements are classified on what basis? On the basis of increasing order of atomic masses. That is what is periodic function. Once again I am repeating, periodic function means the elements with similar physical and chemical properties are placed in the same group, but every time they are placed in a different period. Same group only, but different period. That is periodic function. This law is very, very important. Why? Because modern periodic law also almost resembles the same. So what are the contributions of the Mendeleev's periodic table? So why this periodic table is very, very important? First of all, this periodic table is called as short form of the modern periodic table, students. Why? Because almost same like modern periodic table, but why we are not following? There are exceptions that we'll discuss in the coming slides. So look at here. Mendeleev periodic table simplified the study of elements. The main significance is Mendeleev classified almost all the known elements at his time. This is the first advantage. Yes or no? Look at Dobrin here, look at Lavoisier, look at Newland. Are they classified? Are the laws given by these scientists followed all the elements? This law followed by all the elements? No. But whatever the law which Mendeleev gave, that is followed by all the existing elements at that time. Almost like 56 or 60 elements are there at that time. So he classified all the elements. That means whatever the law he gave, that is applied for all the known elements at his time. That is one of the advantage. And the second significance is not leave known elements. He even predicted unknown elements also, and he left spaces in the periodic table. Not all the elements were discovered at that time. Yes, students. He discovered some unknown elements and he gave certain names also. For example, the element after boron group wise is called, he gave as Eka boron, he called as Eka boron. Later on it is discovered and called as scandium. Next, he named the element after silicon as Eka silicon, which is called as germanium, and Eka aluminium, which is called as gallium. These are the main points you have to remember. This is the second advantage. Mendeleev predicted unknown elements. Mendeleev predicted unknown elements are how? How does he know? By analyzing the properties, students, of by analyzing the properties of the before elements and after elements, top elements, bottom elements. How he classified group wise and period wise. That is the main advantage of this classification. So these are main points, and Mendeleev's periodic table helped in correcting the atomic masses of the elements. He corrected the atomic masses also, like beryllium, osmium. So some other elements also, a couple of elements he corrected the atomic masses. Why this is the significant point? Because his classification is done according to the atomic masses. If an element atomic mass is followed wrong by other scientists, so what does it mean? Can we get the same property? Can we assign the same property? No. He corrected the atomic masses. Beryllium, for example, let us take an example with beryllium. Beryllium atomic mass, previously they thought it is 13.5 grams. It is being calculated using equivalent weight into valency. So, but he corrected from 13.5 to 9, and he gave a particular fixed position to beryllium in its position. So, like not only beryllium, couple of other elements also, he corrected atomic masses. So this is also one of the main significant points. So these 3 points, he classified all the known elements, predicted unknown elements, he corrected the atomic masses. That's why these are all the contributions by Mendeleev. There is an element which is named after the scientist Mendeleev, students. The element is called as Mendelevium in the honor of the scientist. So next, limitations. So if this periodic table has this much of significance, why we are not following? Means there are certain limitations to this periodic table. So let's see what are the limitations of to this Mendeleev's periodic table. First of all, the position of hydrogen is not correctly defined. Position means, students, hydrogen he placed in the first group. If he placed hydrogen in the first group, the question is, why not in the 7th group? Why? Because students, hydrogen can behave like metal and it can also behave like non-metal. That means hydrogen can lose electrons like metal, it can gain electrons like non-metals. If it is placed in the first group, why not in the 7th group? So why not in the 7th group? It can behave like first group elements like as well as 7th group elements also, like halogens. So if it is placed in the 7th group, why not in the first group? That's the confusion. So the position of hydrogen element is uncertain, which he didn't explain about. So next, anomalous pairs of elements. And what is the meaning of anomalous? Something which is not following is called as anomalous. Yes or no? Something which is not following the order, where the remaining are following. So that is called as anomalous. Look at here. We have some anomalous pairs of elements like argon 40, potassium 39. So Mendeleev's classifications in the beginning clearly have said this classification is according to the increasing order of atomic masses. Sir, no, student. Increasing order means what? From lowest to the highest, right? Clear? But look at here. Argon's mass is how much? Argon's mass is 40. Potassium mass is 39. Which element should be placed first? First potassium, next argon. Yes or no? But he placed argon first, followed by potassium. Why, you guess? These couple of elements, this set of two elements are not following the Mendeleev's law, but still strictly he know, but he placed. Why? Why? Because if shifting the places, these places according to his law are not adjusting the properties of the certain groups. For example, potassium belongs to the first group elements, and what about this? Argon belongs to the noble gases. How can he place potassium in noble gases and argon in first group elements, alkali metals? Yes or no? So he strictly followed chemical properties, students. Of course, he didn't check about his law, periodic law. He didn't bother about his own law. So he, whatever the particular point, the particular classification is ruling out his own law, but he didn't completely neglected that chemical properties. His main idea is elements are classified based on chemical properties, then only it will help us to understand them easily. So he strictly followed the chemical nature and he classified. Of course, he followed his law, but for certain positions he ruled out his own law, like this. And look at other example, cobalt and nickel also. Tellurium, iodine. Tellurium mass is how much? 127. Iodine's mass is 126. Which element should be placed first? Iodine followed by tellurium. Yes or no? But again, tellurium placed first followed by iodine. For these set of elements, it is in the decreasing order or not? His law should be in the increasing order. Why he placed? Tellurium is following 16th group elements, iodine is following 17th group elements. So that's why he placed like this. So what is his main preference? His law or chemical properties? Chemical properties is the main preference. So which is good, but according to the law, it is a drawback. Next, isotopes have not been given separate places in the periodic table, students. So isotopes, what are isotopes? Elements, atoms of elements with same atomic number but different mass number. Let us take the talk about the isotopes of hydrogen. What are the isotopes? Protium, deuterium, tritium. These are the isotopes of hydrogen. Yes or no, students? So why do he need to classify about the isotopes? Why? Because his classification is done according to the atomic masses. If protium is 1 gram, what is the next element should be placed? Deuterium 2 grams, next tritium 3 grams, next helium 4 grams. But did he classify all these protium, deuterium, tritium? Not only for hydrogen, almost all the elements have isotopes. Did he classify all the isotopes? He didn't classify it. That's why it is a drawback. Why it is a drawback? His classification is according to the increasing order of atomic masses. All the isotopes have different masses. It's not about same element or different element. It's all about increasing order of masses. That's why it's a drawback. But he know why he didn't classify it. You also know why. Why? Because protium, deuterium, tritium belongs to the same hydrogen element. For the same element, is it okay to give different positions? No. If you give different positions for all the isotopes, the whole periodic table looks clumsy. Yes, sir, students. To avoid that, simply he didn't classify the isotopes, but he has to classify. Why? His law is based on atomic masses, and isotopes have different masses. But he didn't classify it. Why? Because he don't want to disturb the classification by adding all these isotopes, which no use. The same property, the same element, same property. Next, lanthanides and actinides were not given proper places in the Mendeleev's periodic table. So Mendeleev, modern periodic table, there are 18 groups. Mendeleev classification, student, there are only 8 groups only. So where does he placed D block elements and lanthanides, actinides? You know, students, these elements that he included even in the non-metals also. So he didn't classify separately D block, separately lanthanide, separately actinides. That time there is no that much of idea about these electronic configurations also. Simply he made each group into 2 subgroups, A and B, and he added all these D block elements and F block elements under this main classification only. He didn't give any separate position, which is a drawback. And certain chemically dissimilar elements have been grouped together. Just now I said some metals are placed in non-metallic group. For example, manganese, which is a D block element, placed in the non-metallic group. So why? Because the reason is electronic configuration. First of all, at that time there is no complete idea about the electronic configuration, as well as chemical impurity also. Mendeleev almost he checked the chemical properties of all the elements, all the known elements, and during that time not all the chemicals are pure. Yes or no? Why? Because some elements can easily reactive under the normal condition. So to check the properties of the particular chemical, it's not so easy to get the precise properties because of the chemical impurity and because of lack of knowledge of these configurations. Also he added some metals into non-metallic group. Metals means mainly d block elements into non-metallic group. So these are all the reasons why we are not following Mendeleev's periodic table. But this classification is very important classification. Why? Because his law is very valid law, and we are following modern periodic table which has the same law like the Mendeleev periodic table, students. So that's all about the early attempts of classifying the elements like Lavoisier as well as Dobrinier and Newlands, Lothermeyer and Mendeleev's. So the next classification is modern periodic classification, which is very important classification that we'll discuss in the next video.